Okay, I think we're good to start. And this is actually our last chemistry squad for this term, which is always a little bit sad, but as they say, all good things have to come to an end. We're just going to let everyone get comfortable for the first 5 minutes or so. I do have my trusty old cup of tea, so we'll just let a few people join, and then we'll just dip right into chemistry. Today we're going to focus on polymers. So it's going to be a great, fun topic to sort of finish off this round of chemistry squads with. So we'll just let a few people just sort of drift in, and get comfortable. We'll give it maybe 5 minutes or so, and then we'll just jump right into it. How is everyone? Hopefully everyone's doing well. I know Easter's coming up, so I'm sure for a lot of you, study leave is becoming more and more of a reality, which might be a little bit daunting, but I'm sure you guys will smash it. You guys have been working really, really hard anyway. Just because it's the last session, I might stick around for a little bit longer than normal. If any of you have any questions about revision or any questions at all about any tips for chemistry, then by all means, I'll stick around a little bit longer to answer them. Deary me. I see a few more people drifting in. Don't be afraid to say hello. Do pop a smiley face or a hello in the chat. It'd be great to hear from all of you new or returning viewers. It's always great to see all of you join our chemistry squad this evening. We're going to learn a bit about polymers today. If any of you have missed the previous squads, then by all means do make sure to click on I think there's a playlist on the My Tutor YouTube channel where you can watch some of the previous ones, so do make sure to check those out. Also, shout out to Inga as well for being our fantastic moderator in this series. She's been really, really patient even when my timekeeping's not been the best. So massive shout out to her, thank you. It's been fantastic working with you, and hopefully we'll work together in the future. Reham, hello, good to see you. Still rocking the amazing Psychic A profile picture. Great to see you again. Hope you're well. Hope chemistry is going well also. It's great to see you join for our last chemistry squad of this academic term. I can see a few more of you have also jumped in, so don't be afraid to say hello. Hi, Charlie. Good to see you, buddy. Thank you for rejoining our chemistry squad. I've always wondered, what is your profile picture? Is it a dragon? I don't know whether it's a dragon or not. I'm not too sure. It looks like a pattern of some sort, but I'm not too sure what the icon is. It looks really cool, though. Really colourful. I've always wondered what it is. I've never asked, though. It's just swirls. Okay, well, swirls are cool. You know, you can't beat a good old-fashioned pattern in terms of a good old profile picture. But hey, yeah, there you go. That's cool. That's cool. All right. I can see a few more people are drifting in. Just want to say hello to you all again. Thank you for joining the chemistry squad, chemistry stream this evening. This is our last stream of this term. So after this, there won't be any chemistry squads well, I don't want to say for the foreseeable future. I'm sure we'll redo it again. Hopefully, I'll get to do another series of squads. But again, what's really, really important is firstly, make sure you click on the link that Inga has kindly put in the chat. And number two, there will be a feedback form that goes out towards the end of the squad. Also super, super important that you guys fill that in before you leave, because it's my tutor's way of getting as much feedback as possible. If you want the squad to be longer, then just pop that in the form and just say that you want them to be longer. If you want them more frequently, then just pop that in the form. Say you want them to be done more frequently. If you want a completely different presenter that isn't me, then put that in the form and say, I want a completely different presenter that's not NK. All of that feedback is super, super important because it means that my tutor then know what you guys want and how we can support you in your endeavours academically. So do make sure to click on the feedback link that Inga puts out towards the end of the chemistry squad. Okay? If there won't be chemistry sessions, what subject will be next? Well, that's a very good question. It will depend on what you put in the feedback forms. I think generally the subjects change. So when I last did the squad sessions, I did one on study skills. There wasn't a chemistry one, but then this time there has been the chemistry one. So I think what subjects that exist will be dependent on what feedback you guys give, and it'll be dependent on what there's demand for. So we've always had a maths one. We've always had a coding/AI one. The only one that's changed was study squads before, and now it's chemistry. So depending on what it is that you guys want to be covered, will determine, what squad we do next. But if it's chemistry or biology, I'm there. I'm definitely there, down to run those. But anyway, it's 5:05. I say we get right into looking at polymers. Now, I'm going to try and be on point with my timekeeping today, and I'm going to split the session into half and half. Now, I actually popped some questions on polymers on the last YouTube video. If you go through the My Tutor YouTube channel, you'll find the stream from last week, and I actually popped some questions in the comment section there. If you didn't get a chance to do this before this session, absolutely fine. It wasn't homework, it wasn't mandatory, but just know that you have those revision resources there for you to access. If you can't find the YouTube video, just go on physicsandmathstutor.com and then navigate to the appropriate exam board, and you can find some questions there for you to try, okay? But I'm going to spend the first session, or the first part, looking at addition polymerization, and then we're going to move on to looking at condensation polymerization, and that should tidy it all up. Now, before we get into addition polymerization, it'd be great to get some engagement from you guys. What do you understand about polymers in general? So that could be what polymers are, that could be some examples of polymers, some uses of polymers. Let's get some conversation going in the chat, guys. I just want to see what you guys already understand, and then we can build on that. So, absolutely anything. What do you guys understand about polymers? What are they? What are addition polymers? What are some of the organic molecules that can get involved in addition polymerization? So, you said that polymers are used to make plastic. Very good. Charlie, you've also said chains of monomers like polystyrene. Very good. Firstly, I'm loving the examples and I'm loving the definitions. Very good. What other things can we come up with, guys? I'm going to throw something in there that addition polymers are generally made from alkenes, which are unsaturated molecules. So I'm going to throw that one into the mix. What are some other examples of contributions with regards to polymers? What else comes to mind immediately? What can we think of? I don't want to give away all the answers, especially because I know all of you know the answers. It's just about popping them into the chat. So what else comes to mind, guys? What do you think? Okay, Riam, you said condensation polymers produce water. Very good answer. Yes, condensation polymerization generally produces water or a small molecule of some sort. When we get onto condensation polymerization, maybe in the second half of this session, I'll talk a little bit about the term condensation, because most of the time, yes, at GCSE it's water. At A level, if you tend to take it on at A level, it can be other small molecules like hydrochloric acid, like HCl. But yes, generally it's water. Let's have one more response. What is another fact related to polymers, either addition or condensation? What do we think, guys? Let's get one more response. What else comes to mind? Okay, no idea. That's fine. That's fine. No worries. I think you guys have mainly got the bulk of them. If not, give me an example of another polymer or a product of something that polymers are made of. We've already said plastic. If we're not too sure, I'll give one more example and then we'll move on. Hi, Misam. Good to see you. Thanks for rejoining our chemistry squad this evening. It's great to see you, buddy. Okay, so Charlie, you're close. I wouldn't say polyethane, but polyethene or polyethene, which is just general plastic. And you have two types actually. You have low density polyethene and high density polyethene. Fantastic. So let's get into looking at polymers. Generally, what we can say is that polymers are large molecules, and let's type this out. Polymers are large molecules made up of smaller repeating units. Okay, that's exactly what polymers are. Now, again, you're going to have to forgive me for my drawing skills because, again, as we know, they're not the best. But imagine you've got a triangle here, a triangle over here, and a triangle over here. And imagine you've also got a circle over here, a circle over here, and a circle over here. Okay, so you've got all these individual units that then make up a polymer. But what makes them a polymer is when they are arranged in such a way that they are in a repetitive, almost predictable sequence. So if I then put a triangle here, a circle there, a triangle there, a circle there, a triangle there, a circle there, I then have a polymer. Okay, so what we can say is that a polymer is made up of multiple smaller units. Now, does anyone know what the name is for those smaller units? What is the term that we use in chemistry to describe these smaller units? I'll give you a clue. It begins with M. What is the terminology that we use to define these smaller units? Fantastic. So Riam and Charlie absolutely smashed it. You're right. It is a monomer. Monomers are, the monomer is the term that we use for these smaller units. Okay, when they come together, they form a polymer. Okay, now let's think a little bit about addition polymerization and then compare that to condensation polymerization. Okay, so we'll start with addition polymerization. And let's put this in a different color. Let's put it in, oh no, let's go with blue. Why not? Who doesn't like the color blue? So we've got addition polymerization, not condensation polymerization. Generally, addition polymerization is related to alkenes. And as we know, alkenes are unsaturated in nature. Okay. Now, the key thing to remember for your exams when it comes to addition polymerization is knowing what exactly your repeat units look like and how you would draw them. So let's just take ethene, for instance. And again, you're going to have to forgive the drawing because it's not the best. But imagine you've got ethene here, and I'm also going to draw my hydrogens in. So you have this alkene, and what we know is that we can add other molecules to this alkene. We can add other ethene molecules and then make it a polymer. So this would be the monomer, because this is the singular unit. What we then want is the polymer. So the repeat unit could then be drawn like so, where we essentially draw a section of the repeating unit, and we draw some brackets over there and an N. So this is what my repeat unit looks like. Okay. Now, obviously, forgive the really random lengths. Again, I'm not using my graphics tablet because it makes everything lag. But what we can see here is a repeat unit of polyethene. Now, the reason this is a repeat unit is because here you can see on the screen that you've got what would be the section of the polymer. Because if I was to sort of draw out ethene multiple times, they're all bonded to each other, it would look exactly like that. So by isolating a section of the polymer, if I then put N next to it, where N could be the number of individual units that make up the total polymer, I could then draw that out N number of times. So if the polymer consisted of 9 of these units, N equals 9, and I would just draw this out 9 times. If N was 15, then I would draw what's in my bracket out 15 times. Does that also make sense? Hopefully it does. Give me a quick thumbs up in the chat if it does, thumbs down if it doesn't, or a sad face if it doesn't. Again, just want to make sure that we're all on the same page. Okay, fantastic. I see a yes from you, Reham. That's fantastic. Thumbs up from Charlie. Fantastic. Hopefully we're all good so far. I'll give it another minute, and if so, then we'll carry on. Lisa, great to see you, and I'm glad it makes sense. So, Misam, you've asked, would you add the new monomers onto the ethene? Well, remember that the ethene is the monomer, okay? So, essentially, what would happen is if you take multiple units of ethene, you put them together, you then have a string of ethene molecules. Now, I can appreciate that part of the challenge here is that it looks like ethane, but what you need to remember is that it's not ethane because ethane consists of 6 hydrogens with 2 carbons, but here we've only got 4 hydrogens with 2 carbons. So we can see here that it's definitely ethene. Yes, we have no double bond, but that's because the double bond is opened up, so we can add more ethene monomers along the molecule. Okay, hopefully that answered your question. Give me a quick thumbs up if it does. And if so, I would like all of you to come up with some examples of some addition polymers. Just 3. We'll come up with 3 examples. I know I kind of asked this question earlier, but it's just to give you a bit more perspective on it. I will start with one example. So Teflon, which is the non-stick component in frying pans, is an addition polymer. Okay, I believe it is polytetrafluoroethane is what non-stick is, if I remember correctly. So Rem, you said nylon. So nylon is a polymer, but nylon's actually a condensation polymer, which we're going to actually look at next. We're going to look at condensation polymerization next. It is an example of a polymer, but not an addition polymer. But good suggestion all the same. Are there any other examples of possible addition polymers that you can think of? We've already mentioned plastics. So Charlie, you said polybutene, polydecene, polyoctene. Yes, all of these are also examples of polymers. Fantastic. Essentially, it's just anything that's an alkene, really. So any alkenes make up your addition polymers. Okay, fantastic. All right, polystyrene, also a good example of an addition polymer. So that nice foamy stuff you get when you're unpacking boxes, you get polystyrene. Okay, fantastic, guys. You guys have smashed it so far. Super proud of you. Right, let's move on to condensation polymerization. Okay, so what I'm going to do is I am going to... I'm going to clear the board. Fantastic. So let's think about condensation polymerization. And I'm going to do this in... Someone give me a color. First person to give me a color decides which color we're typing in for condensation polymerization. First color I see. There's a drum roll right now. Okay. Oh, Misam was first there with purple. I'll tell you what. Because Misam and Lisa, because it was kind of around the same time, we'll go with purple and green. And I guess we can add in pink as well, because pink is just a variation of purple, I guess. So that's what we're going to go with. Purple, pink, and green. Those are going to be the colors that we go with. So let's start off with purple. Now, if we think a little bit about condensation polymerization, my first question is, what comes to mind when we think of condensation? So I did that in purple, so I'm going to do the next bit in green. Oh, hang on, that did not turn to green. That's not what I wanted. Hang on. That's not quite green. There we go. Okay, so Charlie, you've said small molecules. Misam, you've said getting smaller. Oh, I can see how, condense, if you condense something, yeah, okay. Related to small molecules, though, yeah, that's what, I think we're all on the same page. So when I think of condensation, I think of water. So I think of where you have like mist, for instance, you have condensation at the window, you get water droplets. And this is all relevant, okay? Condensation polymerization is generally the consequence of 2 different molecules with different functional groups reacting to form a polymer. Okay, so this is generally what condensation polymerization is. It's where you form a polymer, but the polymer is made out of 2 different monomers. Okay, so that's the important thing to remember. Unlike addition polymerization, which generally can only involve one monomer, because it's just an alkene, condensation polymerization generally involves two different monomers because they've got two different functional groups. I'm going to use an example, and because we said pink, I'm going to use pink to draw the molecules themselves. So now my question is, can I draw pink? Can I do it in pink? Okay. I'll tell you what, I will, because I'm a man of my word, I will change this colour to, okay, no I can't, fine. I will draw the molecules in black, and then the next thing that I type, I'll type in pink. So, the example that I'm going to use is I'm going to use ethanol and ethanoic acid. Now, hopefully all of you can answer this question. If I take an alcohol and I react it with a carboxylic acid, what is the resultant molecule? What is the molecule that I form? What do we think? What is the resultant molecule when I take an alcohol and I react it with a carboxylic acid? Let's see who feels confident with their organic chemistry. Yes, so your carboxylic acid would be your COOH, that's correct. So if I take an OH from an alcohol and I react it with a carboxylic acid, which is your COOH, what is the resultant molecule? What comes to mind? I'll give you guys a clue. It's a molecule that begins with E. It's got 5 letters and it begins with E. What do we think? Who wants to have a go and guess? If we're not too sure, absolutely fine. We'll still go over it all the same. Okay, Charlie, yeah, you're on the right lines, buddy. Yeah, it's the ones that smell, that have a bit of a fruity smell. You can't quite remember them. Okay, that's absolutely fine. But they are esters. So I'm sure all of you had that in mind. Okay, esters. So esters are what you form when you react an alcohol and a carboxylic acid. Okay. Now, if we were to actually draw the reaction, what we could say, so you know what, just for ease, I'm going to draw methanol. Okay. So this is my alcohol. This is my methanol over here. And this is my carboxylic acid. OH. So this is methanol. And this, no, that's methanoic acid, sorry, and this is methanol. If I were to take these things and react them, what I then end up forming is something called methyl methanoate, okay? Where I then have something that looks, hang on, let me just get the eraser. There we go. And I get something that looks like that. Okay, you get methyl methanoate. Now, this ester is not my only product. I also form water. Okay, so just as a bit of a quick recap, and this I can type in pink because I can change the text color with the color wheel. So we'll change this to pink. I can take, there we go. Okay, an alcohol and a carboxylic acid produce an ester. Okay, so here methanol and methanoic acid produce methyl methanoate and water. And when it comes to naming these esters, it is really, really easy to remember what goes where. So whatever the name of the alcohol is contributes to the alkyl part of the name. So if it's methanol, it's methyl. If it was ethanol, it would be ethyl. If it was propanolol, it would be propyl. Whatever the carboxylic acid is will then determine the second part of the molecule. So since it's methanoic acid, it'll be methanoate. If it's ethanoic acid, it'll be ethanoate, and so on. My next question to all of you, though, is this a polymer? Yes or no? And why? Is this a polymer? If so, why? If not, why? So we've got a very strong no from Charlie there. Okay, why is it not a polymer? Okay, Charlie, you smashed it, buddy. It's not continuous. Okay, so yeah, well done. It's not continuous. Remember that for a polymer to be a polymer, it needs to consist of multiple repeating units. Okay, but the reality here is that this isn't a repeating unit. Okay, instead what you have is two units coming together to form a larger unit, but that's it. Okay, there is no repetition there. So what we do instead is we use what are called dimonomers. And a dimonomer is where you have the same functional group on different sides of the molecule. So let's do that as an example. Okay, so I'm going to clear the whiteboard space again. And we're going to draw an example of a dimonomer. So I could draw, instead of ethanoic acid, I could draw diethanoic acid. Okay, so what I've got over here is the same functional group, but on two separate sides of the molecule. And then I could draw an alcohol, but with the same OH group on both sides of the molecule. Okay? So then the consequence is that even when this group over here reacts with this group over here, I still have this group over here that can react with another OH group on a separate molecule. So then the consequence is I can continuously add more dimonomers as I go along, and that is how I form condensation polymers. So unlike previously, where I just had one functional group per molecule, and those functional groups would react and that's it, I can't extend the chain, in this instance I can extend the chain. And the reason I can extend the chain is because I have difunctional groups. These dimonomers allow me to extend the chain as much as I like. Okay, and that is the thought process there. Does that make sense for everyone? Give me a quick thumbs up if it does, a thumbs down if it doesn't. Is there anything that you'd like me to explain? Absolutely fine if so. The aim here is for all of you to understand the underlying chemistry. I've got a thumbs up from Charlie. Fantastic. Misam, you said kind of. Okay, what would you like me to sort of say so that hopefully you're a bit more confident by the end of it? What do we think? Can I go over that last part? Absolutely fine, Riam. Absolutely fine. So, unlike before, where I had an alcohol and a carboxylic acid and I put them together and I formed an ester, unfortunately, that's not a polymer because there's no repetition. I have one unit of each and that's that. Okay, I can't have a repetitive chain. Here, on the other hand, because I've got a dimonomer, i.e. I have a functional group on both sides of the molecule, even when one functional group from each molecule gets involved in a reaction, I could just add another dimonomer. Because on the other side, and I'll just draw it here, I've got this functional group, which can react with another carboxylic acid on another molecule, and I have this functional group that can react with an alcohol group on another molecule. And so I can keep adding more and more dimonomers so that I can extend the chain as much as I like. And this is what you would refer to as a polyester. So it's an ester group, but I have multiple units that make up the ester group. So this would be a polyester. Okay. Hopefully that clarifies things a little bit more. Give me a quick thumbs up if it does, me, Sam, and Reham, and anyone else for that matter. Does that make sense for everyone? Thumbs up from Reham, fantastic. And me, Sam, what about you? Do you feel a little bit more confident? Fantastic. Smashed it, guys. I knew you'd get it. Well done. And actually, that is perfect timing. As I promised, I said I'd be better with timing, and I've been a lot better with timing because that actually brings us right up to the end of the session, at least from a chemistry perspective. As I mentioned before, Inga will kindly be putting a link in the live chat. Please make sure you fill in the feedback form that that link leads you to, because that is what we need at My Tutor to develop these courses and develop these live streams so that we can make them exactly what you want them to be. Okay? At the end of the day, there are no squads without you. And I did want to say thank you to all of you who have joined, whether you've joined from the very, very beginning or whether you have joined us midway through. It's been really, really fun to have all of you join every week and get engaged and learn chemistry as a consequence. And I feel really, really proud of all of you for your development, but I also feel very honoured that I was able to sort of talk you through some of these key concepts for chemistry, and give you guys that extra little push, that little bit of confidence, just to recognise that you guys are absolutely brilliant with chemistry. So thank you for joining. Honestly, it means a lot to me, and it means a lot to all of us at My Tutor. So before you guys leave the live stream today, please make sure you fill in the feedback form that Inga will be putting in the live chat. Because the more feedback we get, the better. It means we know what to do next time. It means that we know what to do better with. We can really listen to what it is that you guys want, and then we can put that into action for the next round of squads. Yes, Sam, it is the last session for this term. I don't think it'll be the last session ever. I'm sure there will be other sessions in the future. But yes, this is the last session for this term because Easter's coming up really, really soon. So this is number 10. So yeah, all good things do come to an end, but I'm sure, there will be other squads that happen in the future. I will stick around for 5 more minutes or so. So if any of you have any questions at all about chemistry, about revision, the chemistry questions don't have to be about just polymers. If you have a chemistry question in general, I'm more than happy to answer it. But yes, if you do have any questions, I will stick around for 5 minutes or so. And after that, that's that. And hopefully I'll see you in the next round of squads. Riham, you're so welcome for the lesson. Thank you for joining. It's been a pleasure having you. All the best for your GCSEs. Okay? Sam, will I be doing squads in the future? Potentially. Potentially. It really depends. Well, firstly, it depends on the feedback. The more feedback we get, the better. So if there's positive feedback, as for me as a presenter, then sure, I'll do more squads. If there's not positive feedback, then I might hand it over to someone else. But, that's absolutely fine. All of us at My Tutor are more than capable of doing these squads. So, if not me, then by all means. What is the best way to revise for chemistry is what Lisa's asked. I think it's a multidisciplinary is not the right word, that's medical. It's a multifaceted approach. I'm a fan of writing notes and doing past paper questions and marking past paper questions yourself. If you don't already, check out examiners' reports as well when you're marking them, because they give real insight into what the examiner thinks and feels about how candidates answer certain questions. I think, Lisa, to answer your question in more depth, it depends on what type of chemistry you're looking at. If it's calculations, just practicing calculations over and over again. If it's more the content stuff, then definitely writing notes, going over your notes, and then practicing past paper questions. I definitely think that practicing questions and marking them is the way forward. I'm pro doing that. You're more than welcome, Charlie. Thank you for joining every week. It's been a pleasure having you, buddy. I know you say thank me, but thank you, because again, there is no squad without you and everyone else that joins. So, not a problem, buddy. It's what I'm here for. Two more minutes or so to stick around. Actually, no, you know what? I'll hang around for 3 more minutes, because then the squad ends at 40 minutes exactly, which is a nice rounder number, I suppose. Or rather, the squad can, I guess, run until 40. Yeah, a nice round number to end on. If anyone doesn't have any other questions, then by all means, do feel free to ask. And you're more than welcome, Lisa. More than welcome. I'm glad that answered your question. So, Misa said, thank you very much. You've helped quite a lot. Love the way that you teach. Well, thank you so much for that. I think like my teaching style, for any of you who have watched like Crash Course, I think Hank, one of the presenters, is like an inspiration for the way that I teach. Really energetic, um, trying to be thorough. Well, I try to be thorough. Obviously, he is incredibly thorough, but I guess he's one of my inspirations for the way that I teach. I think another inspiration is my A-level chemistry teacher. Actually, really stern guy, but I thought he was brilliant. So that's how I tutor, both on the squads and individually one-on-one tutoring on my teacher as well. So saying thank you. I'm glad that you've enjoyed my teaching style, and I'm glad that you've gotten benefit out of the sessions. So again, that's what we're here for. Make sure to pop that in the feedback form though before you do leave, because then it means that we can capture all that information and then we can really look at it critically, and then we can see what it is that you guys really want from it. Well, from the squads anyway. Okay, guys. Well, this is officially the last chemistry squad of this term. Um, we're always here at my tutor, so if you ever have any questions about chemistry or any other subject for that matter, you can reach out to any one of us at my tutor, and someone will be there to help you. And hopefully, I will see you all in the next squad session, whether that's chemistry, whether it's study squads, whether it's biology. Hopefully, I will see all of you soon. And if not, I wish every single one of you the absolute best with your GCSEs. I'm sure all of you will smash them. You've shown me that you're more than capable of doing the very best that you can and achieving your aspirational grades. Super proud of every single one of you. And I will talk to you all very soon. Oh, Misa, we have one question. How could I contact me if I want to ask something? I have a profile on my tutor, so you could reach out to me at my tutor, and then if you had any questions about anything chemistry or biology related, or even just revision related, you're more than welcome to ask. Oh dear, that was that was one of the pages from work. Sorry. But I'm not on call this evening, so that's fine. But anyway, so that was a really loud noise. Hopefully, I've not destroyed anyone's headphones or anything. But otherwise, I will see you all soon. But again, all the best for the future. Just keep studying hard. Just keep doing your best. Thank you so much for joining, and I will see you all soon. Hopefully. Bye, guys.